All right. So you guys remember that the quiz was moved to Wednesday? So if you don't, you're like, oh, thank God. I'm not saying you sound like that, but maybe you do. See, real quick, Felix, Alex, Grace, Antonio, Maria, Maria, come on. People will tell me they're not going to be here. I won't do their stuff. Andrea, Castillo? Yep. Yay. Alex. Katie. Kimberly. Michael. Georgina. She's okay. Is it right? Yeah. Okay. I may need the copy. It was one side was practice for Wednesday's probability quiz, and the other side we did in class. Okay. So the first part of class today is going to be focused on questions from this. I think the very first thing I want to do is create the formula sheet that we need for the probability quiz. Hopefully some of you learned a lesson. Only put the stuff that I say you can. There must be a reason there's some things I don't say you can have it. That's true. This is that chapter 3, double quiz. Formula sheet. Okay. So it's going to have all those probability formulas. Like the very first one we look at is this guy. What is OR basically? What does OR mean basically, operation-wise? Add. OR is basically add. OR is a nice bouncer. It adds more and more people that can go in. And is the mean bouncer. Yep, options. So it's the two added together, but why do I have to adjust it a little bit? And how do I adjust it a little bit?
Overlap, so you have to subtract.
Exactly, in case they overlap. So that would mean if they did overlap, you counted that overlap twice. Because that overlap is in A and B, so when you added them, you counted it twice. So you subtract it off once. It's crazy. And then what about A given B? You write it the way you'll see it. Thank you. Divide what? What goes on the bottom? Yeah, the given. Whatever's here, that's going to go on the bottom. And what goes on the top? A and B. Like, if B happens, the only way you can be an A is if you're an A and B. Okay, and then we actually use this to get a formula for this. This is related to like The haunted house problem where the Democrats, Republican stuff, the probability of getting so many times, the probability that the next person happens, given that this one did. So if you did it without replacement, this guy actually changes. Right? That's what a given does. It changes based on what happened already. You're like, okay, dude, whatever. Give me the formula. Let's see, anything else from the probability stuff? This is only chapter 3 quiz on Wednesday. It's not going to be the XP of X stuff yet. Stuff we just got into last time.
Do we have the test of independence?
That's an idea. So we can talk about that. But I want to put it up here yet.
How would you use those? Can you give examples?
Sure. All right. Sure. Let me. I don't want to put anything up here yet because then somebody can go, well, you put it up on the board, man, so I thought I could have it on my phone. These are the formulas. Anything else I put up here after this cannot be on your formula sheet. Unless, does somebody have another suggestion for a formula? Okay. So let's do two things. We'll talk about the test for independence, and we'll look at the practice. I gave a practice quiz, so, all kinds of problems on that sucker. Has everybody got this stuff here? Okay. So the test for independence. What do I look at to see, to check A and B for independence? I'm not checking to see if they have babies together. So I probably should write. That's why I was thinking about that joke on the way there. So it doesn't make any sense that your test would have nothing involving how they interact. You don't say, well, probability of A doesn't equal probability of B. Why the hell should they? Why would two separate things, the probability that I trip on the way back to my office versus the probability that my car tire blows out, they should have nothing to do with each other. Why the hell would their probabilities have to equal or not? Nothing. It should be something involving how they interact. And the only probability that really shows how one thing affects another thing is the given. That's got to be a part of this. So if the probability of A given B is still the same as what the probability of A was before B happened, then effectively A doesn't care that B happened, right? So how should we determine that? What should we call that? If A doesn't care that B happened, that would be independent. It actually makes sense with our language. Holy shit. Math doesn't always do that. We pick some weird-ass words sometimes, so it's just the way it is. We're our own language, so leave us alone. But if this is true, if B happens and A doesn't change, he doesn't care, then A and B are independent. Otherwise, they are dependent. Don't hold it like that, Jeff. There you go. Still just as bad. Okay. Yes?
So it's always going to be based off of the first letter?
It doesn't matter. If the probability, alternately, you could do, if the probability of B given A equals probability of B. Is that what you mean? That
Yeah.
this?
Yeah.
Because then it's still independent. Then A and B, independent. Blah, blah, blah. Right? Because this is still fundamentally a probability of A. So if I say the probability it's a dude given they came off of a motorcycle, that is still a probability that it's a dude. So I'm going to compare it to another probability that it's a dude. Those are comparable. So the probability of B, given it, does that equal the probability of B? I mean, it makes sense to compare them because they're both talking about the same thing. It's talking about B, and this is talking about B given that something else happened. If they are the same, then B doesn't give a shit that A happened. Like, that's nice, A. I don't care.
So if it was A for probability, it would be dependent.
How do you, is this equal to probability of A or something?
Yeah.
That would mean that it doesn't equal the probability of B. That's what's important. I think you're
Oh.
getting a little too focused on something. The probability of B, if it doesn't change, if the probability of B, doesn't this say the probability of B?
Yeah.
And then there's like more to the sentence, but doesn't it say the probability of B? Give it an A. And doesn't this say the probability of B? And then the sentence stops. But they're both a probability of B. They are, so it makes sense to compare them. And if these are the same, A happened and B didn't care. Please let that make sense. It just makes sense. Even outside of a math class, it just makes sense. All right. My mom moved. I don't, that's not. Well, I love my mom, but like if you had like somebody you don't even know, hey, that guy Tim, he moved. You're like, why should I give a shit? Unless he moved to my house, and then I'm like, no, I'm freaking living there, right? You guys understand? I mean, if you're independent, one thing does something, I won't care. So if this is not equal to, then they are dependent. If this wasn't equal to, then what's probably B? Well, it depends on if A happened. If A happened, it's different. That's where the word depend come from. Please let that make sense. Don't ask me to explain it another way, because that is the most basic way to explain it. Period. So don't answer that kind of question with, well, you don't have to be. No, you're already wrong. Your answer should start with this. And then you show me the numbers, and then you can say independent, dependent, based on what they are. Right? So it's very much more mathematical answer. A few words, sure. But if you're writing the paragraph, you're probably wrong. Okay. What was the other question? You just wanted some examples, and I have a whole sheet of examples. I gave you guys I just gave some more people the practice quiz, all right? Yes. Oh, you need one? Yes. Anybody else need that? Okay. So on the one side of that was what we did in class. That's been captured by the camera, put on the YouTubes, on the internets. Internet's a series of tubes. YouTube is one of them. Okay, so now I'm going to throw wide open to questions from that sucker, or questions from homework. Right? If you're like, well, I didn't do this just because I was so busy doing my homework. Okay, you got questions from homework then. Questions from somewhere. Yes?
Can you do 51 for an hour?
Okay, so we got to kind of build up to it. Let me throw it up here real quick. Well, this is not going to be quick. So this is the one that's, they tell me that 48% of all California registered voters prefer life in prison without parole, that kind of problem, right? Initializing. You do it, system. There you go, system. Yay. Whoa, crap, did you do that? There you go. Okay, I want to get that kind of whole setup there. Pow. So if you don't have your book. So which one you asked about? 51? 52? 51, thank God. That's please not anything past 51. So at this point, you've done all of these, right? So you know these, you know this, that leads you to this. So the way you do this kind of problem is, we did one of these, I think we looked at this a little bit, I think we focused more on the other one. Remember that other wording problem where I showed you, they give you this big paragraph and you just got to tease out the numbers and put the right symbols with them. So, I mean, like the probability of C, Californians preferring life in prison without parole, well, what's that going to be? 48%. They tell you right in your face, right? So a lot of you guys just start trying to do work. No. Look what they tell you already by itself. They got to give you some information, or else you have nothing to work with. So these questions are really just making sure, hey, have you read that yet? Right? So you get this from there, you probably get this from there, you probably get this from there. Let's see, among Latino California registered voters, so among Latinos, given Latino, the probability they prefer life in prison without parole, that's this. Can you see how that's related to this? And I love you guys because you get sitting there going, I have no idea. Well, then maybe ask somebody, me, a tutor, somebody, or accept a horrible grade. I don't know what else to do for you. Checking, Mr. God. So this is really important right now because what's the formula? What is the formula for what they ask you? That's where you start. If I ask you something like this, you write the formula for it, and then you step back and say, do I have these things? So what is the formula for probability of L or C? What's the formula for that? Here, let me show you. People at home, we're looking at that. The people at home. Okay. What is the formula for the probability of L or C? And I always wait for somebody to go, I know the one for A or B, Jeff. Well, then you know the one for this. What is it?
Probability of L.
Probability of L. Probability of L.
Probability
Plus probability of C.
minus probability of variance.
Yeah. So it doesn't matter. The letters are just what's called dummy variables. Why does it have to be A and not L? It could be any damn thing. So it just gives you an idea for any OR question. So 44, 45, 48. You guys see what I'm saying? Number 44, you had to figure out this. Number 45, you had to figure out this. Number 48, you had to figure out this. Throw them in, you figure it out. That's why I do that on the quiz. I ask you questions, and then like this question uses what you did here. This question uses what you did here. Right? Because that's the progression. That's how you do it. I like it. Is that enough? Is that cool? Okay. Yeah.
So or means add.
Good.
And then
Or basically means add.
Okay.
And basically means multiply. I like it. When does it not so important to know that? When I give you everything that you can count. Then you do not need to use the formulas. You can if you want to, but sometimes they'll make it a lot harder than it needs to be. Why do formulas do that, Jeff? You're Mr. Math Man. You love formulas. Yeah, I do, when they're appropriate, right? Formulas are the most general representation of my idea. There are certain situations where I can do it a lot quicker without the formula. Probability is a big example of that. Right? We did a lot of probability questions before we even talked about formulas at all. Yes?
So when you said add or multiply, so which one do we use?
No.
What?
Or is basically add,
No.
and is basically multiply.
Oh, okay.
Okay. I like it. It sucks that the word is and. Anything else from homework or the practice quiz? I have the answer key that I'm going to give you later. Yes?
I'm working on section 3.2, the 40 to 43. The first two, are those like trick questions?
Unfreeze. Unfreeze. Where's my super suit? Oh, here we go. All right, these guys, hell no. Those are not tricks. In fact, I try to get you ready for this. This is a problem that's designed to make sure you understand when I give you information, what does it mean mathematically? Sometimes it has a mathematical meaning. So if I tell you E and F are mutually exclusive, what does that mean?
You can't both have it,
I like it. Now make it more mathematical.
so they don't have anything.
So make it much more mathematical, meaning
It's zero.
what's zero? Don't say it's zero. I don't know what that means.
Probability of it.
The probability of F and E. I love it. So if I say E and F are mutually exclusive, that means the probability of E and F is zero. The probability that they happen at the same time, they can't. If they're mutually exclusive, they cannot happen at the same time. Is that cool?
Yeah.
And then they ask you, what's the probability of E given F? Well, what's the formula for that? Huh? Say again?
It's all given to me right there, so that's why I was confused.
No, it's not. No, it's not. If you didn't write this down, you couldn't answer the damn question. Why not? What's the formula for probability of E given F? What's the formula? Probability of E and F? Probability of F. I like it. That is the formula for it, right? Are you with me? If you didn't write this, then you couldn't do this. Because they don't tell you this. Not directly. They do tell you this, though. What is it? It's freaking 0. So what's probability of E given F? 0. I like it. Yeah, so you're right. I think it's not supposed to be a hard problem, no. But the hard part about it is people just blow past that first sentence.
Yeah.
They're like, that's a bunch of words, what's it matter? Give me some numbers to plug in. No, that's an idea.
Yeah.
That's an idea that leads you to information that you need. Right? I like it. So statistics is fundamentally a reading and writing course, to be honest, with number analysis in there. And then 41, same idea. If I tell you that J and K are independent, what does that mean?
We'll see if J given K is the same as probability.
I love it. If they're independent, the probability of J given K is probability of J. And vice versa, probably K given J is probably K. One does not affect the other one. Yes?
So probability 43.
Oh yeah, I love it. All right, so. You're all like, God, you're weird, man, getting excited about
No.
probability questions. Wow. Makes my job a lot easier. All right. Q and R are independent. 43, right? So what can I write right there?
Q given R.
Yep, probably Q given R equals, you know, R happens. If they're independent, does Q give a shit? No. Therefore, would Q change? No. The probability of Q in this situation is the same as the probability of Q in any given, because it doesn't care. R happened, Q doesn't care. I like it. Now let's see how I can use that. So they tell me the probability of Q is 0.4. The probability of Q and R is 0.1. Find the probability of R. Now this I like this problem. There's no formula for the probability of R. Are you with me? Right? And so if I say, what's the formula for the probability of R? You look at me like, what's R? I don't know. But what's the formula for probability Q and R? What's the formula for that? You can look it up, right? Or the probability of R times probably Q given R, right? So probably Q given R is probably Q. And what else can I write, actually, to be honest? Probability of R given Q is probability of R. So what do they tell me? They tell me the probability of Q. They tell me the probability of Q and R, right? And they want to know what the probability of R is. But look here. It doesn't really matter which way you write this. What's this going to be for this problem? What does this become? What's a better way to write this? It's not R given Q. What's a better way to write? Because we just said, if they're independent, one doesn't affect the other one, right? So then this formula is that's how that formula changes, right? And really, this is without replacement. This is with replacement, because the next guy might change if it's without replacement, but the next guy won't change if it's with replacement. So it's really the same formula. It's just I adjust it if I'm allowing for changes to happen. I take a card and I throw it away. Yes.
So basically 0.4 times 0.1.
Yeah, they told me probability of Q. Careful now. They told me probability of Q. Did they tell me the probability of R? No. But they told me the probability of Q and R. Do you see how I am putting these values into the right place in the formula? And why am I working with this formula? That's the only thing they told me that has a formula related to it. It's got to be that formula I'm going to use. I love the way some of you guys are looking at me. So either you write the formula on based on what they ask you, or you write formulas based on what they give you. Because that thing might be related to what they ask me, and it is. So now I'm going to put a 0.1 here, equals 0.4 times the probability of R. Now how do I solve for the probability of R? Algebra, divide by 0.4. Algebra has a reason, a purpose. Holy shit. That's why I took that shit. Yes, algebra has a purpose. It does. It's amazing. Okay.
For the next one, though, you're supposed to get the answer for that and then divide it by.
Well, I mean, keep going.
Oh, okay.
I basically finished it for you, but I just can't write it for you. I'm going to at least make you guys write it. I don't do the whole problem for you, which I did. Okay. Anything else from homework or the practice quiz? Let me give you guys the answer key for that. One side is the answer key for the practice quiz, and the other side is something we're going to do later today. So just maybe don't worry about this side yet. Just the answer key for the practice quiz. So your next one? It's from my man in front of you there. Right there, yeah. Cool. So you guys see one side is the answers. I decided to give you a break from looking at my horrible handwriting and type them up. The other side is something we'll do later. So right now this side doesn't make any sense. Just leave that side alone. So let me let you look at that for a second. And then we're going to get into some new stuff. The problem that most people have a trouble with, and it's not even meant to be something I'm going to ask you again, because once you see it, you got it. 4C. And I gave you that hint on there. No probability that you calculate ever can be bigger than 1. So my hint was look at probability of A or B. Right? So probability of A or B is probability of A plus probability of B minus the intersection. Well, probability of A plus B is 1.2. So how big must the and be? How big must the and be in order to bring it down back to 1, that the legal place? Well, it's got to be at least 0.2 to bring it back down. That's a weird idea, and it's not a general kind of like thing to know or whatever. I just like to put that down there apparently to freak you out, but to see if somebody can tease that out. Some of you guys are like, you had me at, I don't have to worry about it. Shit. All right. Okay. Anything jump out at you? Any questions about any part of that? Yes?
For number, for number like C, I mean letter C, 1.
1C.
Like, when you say like, around, like the squiggly line, do you just round?
Oh.
And not?
Yeah, you don't have to worry about putting the squiggly line. I mean,
Oh, okay.
it said round decimal answers to 4 places, so that little squiggly equals is like an approximately. It means approximately. And we use that when we round, just to be honest, you know. It's not equal to this, it's about this. Yeah.
Okay.
So I'll say that same thing on the actual quiz. I'll say round to 4 decimal places. And then like I did, I went and made them into percentages in case any of you guys did too. You didn't have to. But that's like the normal human thing to do is
For number 1?
percentages, yeah. For number 1. I guess number 2 I got tired, stopped doing it.
Oh.
But you can make number 2 into percentages also. Yeah. Okay.
So we have to do a percentage or?
No.
Okay, we just give us.
Okay. All right. So anything about that? Are you guys good to move on? I like this. Somebody's like, we'll find out. Show me what's going on, math boy, and we'll see. All right. So I want to remind you, we're not doing entirely new stuff. We're building on what we did last time. We calculated the mean for a different setup of data, right? A data that had a lot of repeats in it. So let's do a problem, and this time we'll go a little further. Let's do a little tiny problem. 1, 2, 3, 4. I like it. 5.3.05.5. There you go, Jeff. Now, if I ask you right now, is this a valid probability distribution? I don't think you would answer that. I mean, what would make this invalid? Oh, well. Is it really that bad?
Well, wouldn't it be invalid if p of x didn't equal 1?
Yes. If the sum of those didn't equal 1, I like it. But there's also another thing that's sort of almost too basic to even think to say, but you're going to have to say it. So if I said, is it valid? You would say yes, because you can use words if you want to, but here's the quick way to say, when you add up all the probabilities, you get 1. Let me see if you guys can handle this. Doesn't have to always be 1. It could be like 0.9999, because maybe I rounded something, but it's got to be close to 1. And the idea of close is kind of like relative, so I'm always going to make it like either 1 or like stupid close to 0.9999 or 1.0001. So if you say, no, it's not valid, I can't do anything, I'm like, what the hell? That's plenty close enough. Just round it. And here's a really more basic thing. Even what's got to be true at all the probabilities? Each probability has to be between 0 and 1. So you got to say, and 0 is less than or equal to probability of x, less than or equal to 1 for all x. So the probabilities have to be between 0 and 1, and they have to add to 1. You got to say both of those things for it to show me that it's a valid distribution. Who remembers how to do the next column to start to figure out the mean?
Multiply x by probability x.
Yes, do x times p of x. Because what is the formula for the mean? It's the sum of x times p of x. What was the other name for the mean? The expatriate? No. Expired? No. The expected value. It's like your best guess. So another way to say it is the expected value. I just pointed out that the formula actually has those kind of 3 letters in it. It's kind of nifty. Or maybe it's just for me. I don't know. It's fine if it is, because I like it. So what do I put here then? Because what's this tell me to do? Yeah, it tells me to take the x times the p of x. So here I get 0.5. You can do it. Double 0.3. 0.6. Triple 0.05. 0.15. Quadruple 0.15. 0.6. Oh. And I should have said something before I even wrote that down. Do you guys see what's the heaviest weighted number? 1 is the heaviest number. So the mean should be drawn down to it. It's like attracting everything. It's like it's the heaviest thing, so it's going to pull it down. Now this is 30%, so it's going to kind of not let it go all the way down to 1. And I got some higher numbers, but look, what do you get? You get 1.1, 1.2, 1.85, is that? Did I do that too fast? You guys get 1.85? 1.1, 1.2, 1.85, that's what I'm getting. All right. So that is the mean. Why? Because that's what I get when I sum up the xp of x, and that's freaking what the mean is. So this is the sum of xp of x, which is the mean. Okay. And remember, I showed you how this is related to the formula we did before. How do I find the average of a list of numbers? I add them all up and divide by the total, n. And what is on the bottom of the probability always? N. So it's really the same formula. It's just kind of like consolidating all the repeats into this probability of x. So of course, what do I still need to figure out? What's the other important number? Standard deviation. I like it. So you need to figure out the standard deviation. So I'll tell you this. What I'm about to write down, let me see how to say this so you understand. Let me make a little thing. You don't have to write this down at all. This is the idea, and then we're going to make a better formula and use it. So here's the mean part, right? That's the mean. Now to get the standard deviation, I do the same thing. I weight. So what's standard deviation based on? What's like the first step if I had to make a table of standard deviations? Once you got the x in there, what do I do next? Standard
X minus the average.
x minus x bar. I love it because this idea of the standard deviation is the distance from the data points to the mean, right? Now, for reasons that will become apparent in a minute, we always assume this is population. So if I did this and then I multiplied it by the weight, do you see here, I didn't add up the x's and divide it by n. I multiplied it by the weight and then add them up. So if I do the distances, squared of course, for the same reason as before, multiplied by the percentage, which I keep calling the weight. Hopefully you guys see what I mean. Like in here, the tests are the heaviest weighted thing because they're the highest percentage. If I add that up, that is the variance. Because it's still squared, right? And then I square root it and get the standard deviation. But this formula kind of sucks because it involves a hell of a lot of work. So you see how the mean is involving the weight times the values. The standard deviation is involving the weight times the distances. And now you see why I have to use population symbols, because again, what's on the bottom of P of X? What's on the bottom of probability? N. And if it's supposed to be S, what's supposed to be in the bottom of the standard deviation? N minus 1. Oh, shit. Okay. Let me stop here for a second. I'm getting a lot of deer in headlight looks at me. So I want you to realize we could do like, I just wanted to fit it before I got here, but I could do x minus mu squared, x minus mu squared times P of X, 3 more frickin' columns, and then finally add up that last column and I get the variance. So I use a slightly different formula. You could use this one if you want to. You can. And I've had people do that. But let me show you a slightly different formula. Maybe the reason people use this next one is because they think they have to do what I'm about to do. I'm going to show you where the formula comes from using some algebra, right? That was creepy, Jeff. Hold on there. Using some algebra, I'm going to show you a better way to write this because I only need one more column here for what I'm about to do to this. I really do just need one more. This involves a lot of like freaking work to get this sucker together. Help me out. In algebra, if you saw this kind of thing, what would you do? If I said simplify that, what would you do to it? No. So in algebra, if I said y minus 7 squared, simplify, what would you do? Multiply it out. Normally it's called the what? The what method? The FOIL, right? And I hate FOIL, but it's too bad for me. It's just repeated distribution. Gives a shit. Right? So you do y minus 7 times y minus 7. And you distribute the y, distribute the 7. I don't know why we need FOIL, but oh well. It's too late for me. So you add one more letter, one more number in here, or letter. FOIL goes to shit. So what am I saying? I'm saying one way to try to rewrite this equation is to FOIL this out and see what happens. So I'm just going to show you the first step. I'm going to bury you, I'm going to protect you away from all the other steps, because this is not a formula rewrite class. But if I FOIL this out, here, I want you guys to do a little algebra. FOIL it out. FOIL it. That piece. FOIL this. Right? That's what x minus mu squared is. I love some of the guys are like, why don't you walk over here and make them do that? Shit. Okay. What do you guys get? X squared minus 2 mu x. I like it. Plus mu squared times p of x, right? And do you see how that p of x would distribute? Okay, I'm not going to do any more of the algebra. I just want to show you at least where the first piece of this comes from so you can see the connection. So a better way to write the formula for variance, it is this. This is the idea of it. Anything related to standard deviation should have this idea in it. Because that is the basic idea. How far away from the middle do all the data points get? But if I work with it, I actually end up getting this. Look at what the first piece of this would be. Sum of x squared times p of x. Isn't that the first piece? You distribute the p of x in there, you get sum of x squared times p of x. And believe it or not, all the other shit in there becomes this. It's hard to believe, but oh well, I'm not going to take us through a summation algebra class. Let's not do that. But if I kept going, I would get to here. That's crazy. This is a very nice formula. Now, some of you guys might be like, I think it's about the same level as this, man, honestly. But look at how, do you see what I need to add? I need to add these. I've got x times p of x. I can very easily make an x squared p of x just by multiplying these two together. What's x times x p of x? X squared p of x. So another way to look at it is, if this is L1, this would be L1 times L3, right? This one, of course, is L1 times L2. And you know I have a handout. If you haven't picked up on that yet, you have now. I have handouts like crazy. So to finish this off, we don't have to use the list. There's only 4 problems here. But so what is 1 times 0.5? Is everybody cool with this? Now, you could do L1 squared times L2. You really could, because that's still x squared times p of x. I just kind of myself, I like to do this. So what's 1 times 0.5? 0.5. 2 times 0.6? 1.2. 3 times 0.15? 4.5. 4 times 0.6? Oh, yeah. No, 3 times 0.15 is 0.45. If you had 2 15 cents, you got 30 cents. If I have 3 15 cents, I have 45 cents. Is that cool? Okay. Now you guys, what's up? Some of you guys have quizzical looks on your faces, but what am I doing? I'm just multiplying these. Why am I multiplying these? Because the formula needs me to get a bunch of those so I can add them up. That's why. That same idea. So I'll make a bunch of those so then I can add them up. So what do I get when I add these up? .55, yes. Now, the next mistake people make is I take a square root of that number, but that's not the formula. What's the formula? It's the variance is that thing minus the mean squared. That's the variance. And then how do you get the standard deviation? You just do what to that? Square root it, so you get rid of that stupid square. Okay, I like it. So whatever the hell that is, I don't know. You guys can help me. By the way, I'm about to give you the handout that you got to work on some stuff. If you need a calculator, you might want to give me an ID and you need a calculator. Oh, you got it? Okay.
I have a question.
Yes.
Okay, I think I'm gonna get confused with the x and the x. Like x times px. I'm gonna get confused by what numbers I should use. You know what I mean?
So this column is the x's,
Yeah.
and this column is the p of x's. So if I have a column, if I have a formula that needs x times p of x, I just multiply these together.
That's different. Okay.
So just to show you, no one needs a calculator? Okay. I like that. Oh. Make sure it turns on. Sweet spot. There we go. So real, just to show you what this would look like in your calculator, if I put 1, 2, 3, 4, that's the data, and then I put 0.5, 0.3, 0.05, 0.15. So that's the. I got to give you both of those. I have to give you both of these. You with me? Because that means 50% on my list is ones, 30% is twos, and so forth. And now how do I make L3? How do I make L3?
You multiply them both.
Multiply who?
1 and 2.
L1 times L2. Bam! Thank God it's the same numbers. And how do I make L4? There's actually two ways, but I would do L1 times L3. Bam! Same numbers, thank God. Is that cool? And then you can just add those up, put them in the formula.
Wait, what did you do before? I was typing it.
4, you go to 4, you go, that's L1, that's x, times xp of x is x squared p of x. So L1 times L3. So let me give you this handout. It's got what I just said on it. Which one did it start? It doesn't matter, Jeff. Everybody's going to get it.
So you have to have the same numbers? Oh, no,
All right, so one side of this should be obvious. One side of this is worked out problem. I even answer some interesting questions that I could ask you, that I enjoy asking you, that will probably be on the quiz or test, or both. And I show you how they all work. There's the formulas we just developed. And then the other side is what I want you to do right now. Oh, yeah. So let's make sure. Good.
And one more.
Yeah. Make sure that turns on. She's got the battery. Who's looking at it too?